iterative methodology or a step-by-step process to do this. I will walk you through the multiple layers that we have, and then we will deep dive into each one of the layers and talk about individual components of each layer that we have built. So coming to the first layer, which is the most important layer, is your driving detection layer. It is all about detecting what kind of vehicle or what kind of mode of transport a person is doing when we have detected the motion. So first part is detecting the motion. Second part is deciding what kind of mode of transport it is. So this is the first important part, and based on this, next parts or the next components are decided. Moving to the next component, which is your component related to the absolute risk. So this is basically assessing the performance of a driver or the risk events without any contextual layer. So this is all complete based on sensor data, GPS data, and whatever data we can collect from the smartphone, purely based on that. And there is no contextualization at this layer. We are just purely assessing the performance of the driver without any traffic data or weather data. So once we have an understanding about the absolute risk, the next step is contextualizing it, trying to understand with the real-time scenario what is happening, and then better assess the performance of the driver. So in this particular layer, the third layer, we get the information about the traffic, weather, and also the historical aspects, which can be divided into two kinds. One is your region-specific historical aspects, which could be like accident-prone zones, and second historical aspects could be related to driver attributes like how much sleep a particular driver took last night, and what is the average time for which a driver drives, and things like that. So these are the three layers which we use to complete the whole picture about a particular event, or to complete the picture about overall driving scenario for a particular driver. So now moving ahead, and so now what we are going to do is basically deep dive into each one of the layers and talk, give a brief overview what is happening in each one of the layers. So first step, as we discussed, is identifying the driving state and the mode of transport. So for this, the raw data that we use is the GPS data and your accelerometer data mostly. So based on the GPS data and your accelerometer sensor in your smartphone, we try to create different kinds of profile for each event that we capture in the smartphone or using our app. The first part is profiling the speed, how the speed changes are happening and things like that. Acceleration profiling, how the accelerations are happening, what kind, how much acceleration we are observing, what amount of G-force we are observing, and things related to that. And then we also try to profile the angle changes. So how frequently the angle of a particular driver when or particular mode of transport is changing. And based on research, we know that how different mode of transport behaves with respect to the direction changes that we observe in the GPS data. So based on this, the raw data and the analysis that we talked about, we build multiple features for every trip. And then these multiple features are passed through your machine learning models to predict what kind of a mode of transport is being used. Firstly, whether it's a motorized transport or non-motorized transport. And then within the motorized transport, whether it's a train, whether it's a tram, or it's a car, all those things are predicted or classified and then used in further layers in our methodology. So going to visually looking at some of the features that we develop, just to give you a very brief understanding or about what kind of things you can observe. So for example, the first chart you are seeing is the chart related to the speed variations or the average speed. So generally, as happened for a trip, the trains would generally have higher average speed as compared to your cars, and cars would tend to have higher average speed with, as compared to your bus. So this is one of the features that we use. Then the second feature, for example, is your auto correlation, where we see that for the train, the auto correlation is generally higher as compared to your car and bus. So this is also one of the features that we use. And third feature, the coefficient of variance. And here also we see some how it can distinguish between different modes of transport. And there are some other features also which we use. and combining all these features and then passing it through the machine learning models to identify the patterns and then make the right classification for the mode of transport. So this is the first layer. Now, after identifying the mode of transport, the second part is calculating the absolute risk without any contextual part to the data. So now here, again, if we talk about the raw data, we are again using the sensor data. Now here we also use accelerometer, gyroscope, and magnetometer, and the GPS data to do all this that we are going to talk about in this particular step. The challenge that is always there with the sensor data is that sensor data is very noisy, and we have to deploy multiple kind of filters to first remove any kind of noise which is present in the sensor data. So for example, we have Kalman filter, which basically fuses the GPS data and accelerometer data to get better estimates about the location and the speed of the driver. Then we have low pass filters to filter the accelerometer data. We also use median filter. And then we have complementary filter, which basically fuses your gyroscope with your accelerometer to give you more accurate readings of your gyroscope sensor. So this is the first important part of calculating the absolute risk regarding the filtering. Now, once we filter the data, we move to the next state. Next step in this analysis is basically again creating some features from the clean data. So we create features like the linear g-forces that a smartphone has observed, and angular velocity, and also we calculate features in the time domain and the frequency domain to get a better understanding both with respect to the time and frequency. So apart from this, one more very important step is related to orientation. So as phone can be oriented in any orientation while a person is driving, it could be in the pocket, or it could be on the dashboard, or it could be on the seat. So it is very important when using smartphone based telematics is that we need to orient the data in a reference frame which is constant. So for example, for our analysis, we use two types of reorientation. One is with respect to the earth, and second is with respect to the vehicle. So we orient all the sensor data to the vehicle reference frame and to the earth reference frame. And once we create all these features, we again have multiple models to detect each and every event. And for each and every event also, we have different layers of model to make sure that our recall is as high as possible and we get less false positive, but very high recall. So we have models like k-means algorithms, XGBoost, CatBoost, and some other models also, which are used to basically generate the risk with respect to the items like speeding, braking, acceleration, turning, fatigue, and distraction. So at this level, we are able to analyze the driver's absolute risk, and then we will visually look at few patterns that we observe in the data. So if you look at the first graph, here it is one of the patterns that is observed for hard acceleration. So you will see that the acceleration is peaking and it's coming down. So the machine learning models try to basically understand patterns like this and then make the prediction about whether it's a hard braking, hard acceleration, and things like that. If you look at the second chart, where we have highlighted distraction pattern, it is one of the distraction patterns. It is the pattern that we observe mostly when someone is continuously moving phone while driving. There are other patterns, like for example, if a person is holding the phone near his ear or texting and things like that. But there are different patterns that are observed. This is one sample pattern that you can see, which basically helps in understanding the distraction. And then there is a pattern related to hard turn, which you will see here. You get a peak, very different kind of peak when there is a hard turn. So this is one of the patterns that we observe for hard turns. So overall, with cleaned up sensor data, we get different kinds of patterns, and then we create features out of these patterns and pass through our machine learning models to basically calculate the absolute risk. So this completes our second step. Now moving to the third step, which is I think the most interesting step that we all want to hear about, is the contextual risk. So how, once we have calculated the absolutes, how to contextualize it and what kind of data is used to do that. So the first part is the real-time road and weather data. So here we capture data like your traffic data, your in traffic data, you have traffic speed, the density, what kind of road weight, road category it is, whether it is a motorway or a city road, what kind of speed limits are there on the road, TMC data, which is used to pass on information between different map services, and merges and exits. And in the weather data, you have visibility, whether there is a rain or snow or traction and things like that. So this is one part of which is real time, which is happening when a person is driving. The second important part is the historical factors. So now historical factors could be understood in two, with respect to two factors. One is the regional factor, which are like accident prone zones. So every city, every uh, country have few areas which are very prone to accident. It might be because of very heavy traffic jams or bad road design, or could be multiple reasons. So that is also important to analyze places where such accident prone zones exist. And second, historical parameters are related to the driver, which is about the sleep cycles, how much generally they drive for long, how long, and also whether they're driving on the route which is familiar to them or they are driving on a route which is not familiar to them. So these are kind of different historical factors that we capture. And then again, we've built features using all these factors, the real time and historical factors. And then again, we have multiple models to basically give the understanding about the relative speed, what was the how was the traffic playing an important role while the person was particular event happened, risk event happened, how the visibility played an important role when a particular event happened, and how fatigue played an important role, whether there was a chances of fatigue or not at a particular instant when some event happened. And basically, after all these, we have further, once we have analyzed all these real-time and historical factors, we overlay it with the absolute risk information that we have generated from the step 2, and then get a better understanding about each one of the risk events that we captured during our absolute risk assessment. And the same things would be analyzed much more better, or better assessment could be done for each of the events. So this is step 3, visually looking at things. So for example, at every event, we have such amount of data which is related to traffic, for example. So we have road category data, whether it's a road category 1 basically means motorways, 2 means some major city roads and things like that. What is the free flow speed? What is the jam factor, which basically represents your traffic density, the traffic speed, the multiple kind of traffic speeds that we get, and weather description, whether it's a broken clouds, whether it's a rainy or things like that, and visibility and wind speed. So these are some kind of data points that we collect for every event and then further assess them effectively. Then other part you can see is contextual risk zones. So we all have historical accident prone zones that we know from historically that accidents have happened at that particular place. But also we can create zones where we know a certain kind of event is happening a lot, which could help in better, for example, better road designs, or which could help in analyzing that these are the areas where people generally have very high, large number of hard braking, hard acceleration, and things like that. So with the Kruzr data, we can create contextual risk zones also, which basically talks about that these are the areas where some kind of risk event is happening at a much higher rate as compared to some other areas. And then there are accident hotspots, which basically talks about the historical accident data, classified based on the severity and things like that, and how all these polygons are created. We will see it in the live demo also. For every city, we have marked regions which are very prone to accidents based on the historical data which is available from different government institutes or government organizations, and plot them to see what are the accident hotspots for a particular city or for a particular country. So this is some visual representation. Now I will talk about do a demo, a small demo, where I will go through each one of the layers and talk about and show them visually how things are happening. So let me share my screen. I hope everyone can see the map on my screen.
Yep.
Okay, cool. So starting with the first important part is the raw data. So for example, these are few of the trips that Ayan has taken and we have populated it here. Uh, so uh, so for example, you can see there are three trips. First, we identify the mode of transport. So for example, this was a train trip. So I will just zoom in a little. Yeah. So this is one of the train trips, and this is the car trip, and this is also one of the car trips that has been taken. Now, this is simply the first layer where we are basically have identified the mode of transport, and using the GPS data, we have been able to identify the correct location at every second for a particular user or for a particular driver, and doing some analysis to create the proper route that we expect a user has taken, and then doing the further analysis on them. So this is the first part of the R analysis. Now we move to intervention or risk events in isolation, which are your absolute risk events without any contextual layer to it. So if you look at it, there are some interventions that you will be able to see. For example, this is one of the heartbreaking intervention or risk event, which basically tells us that it is of the severity medium, and this driver speed at this moment of time was 35.3 kilometer per hour, and the G force which was experienced was 0.37. So for every event, now this event has been captured without any kind of contextual, purely based on sensor and the GPS data. Similarly, we can see a hard turn here, which is also medium severity. Driver speed was 32 and the angular velocity was 23 degree per second. And similarly, there is one hard acceleration event, which we have captured. So these events have been captured without any contextual layer. Now we will see each of the contextual layer, and then we will see how it helps us in making the better assessment for each of the individual risks that we have identified till now. So the first layer that we are going to add is the historical context layer with regards to the region, or you can say the accident prone zone. So when I click on it, you will see some of the accident zones getting populated for Bonn in Germany. So you see there is one accident. We can see there is one accident hotspot here, few accident hotspot here. If I, for example, this is for example the Frankfurt city. As you can see at this level, you can see large number of accident hotspots all around Frankfurt and inside the Frankfurt. So if I zoom in, these accident hotspots have been identified, and we have plotted some polygons to identify or map the areas where a lot of accidents have happened previously, and based on the severity and the different aspects of every aspect. So you will see for every zone or the polygon or hotspot, whatever you want to call it, there is a severity attached to it. What is the severity in this particular hotspot? So and things like that. So you will see this is, some are less severe, some are more severe, depending upon the scale you can see. So you'll see whole of Frankfurt has been covered, and we have covered not only whole Frankfurt, but this is present for whole of Germany for different areas. So if you go to any other city, we will be able to find different hotspots in different areas of Germany. So here you will see some other hotspots and things like that. So now, as we have created these hotspots, so this will give us the historical context with respect to the accidents that has been observed previously. Coming to the second component of historical context is the driver's historical data, which is basically about, this is a demo data for the historical, for example, last night sleep time, how long a person took the sleep, average sleep time that we observe, average trip duration, when was the last trip taken, like for example, 15 minutes before this trip, the driver took one more trip, which was of the duration 9 minutes. So this data basically helps in understanding the fatigueness that could be there while a driver is taking a particular trip. So these are the historical attributes of a driver. So this completes our, this basically is the all the historical data that we capture for every trip. Now, moving to the real-time context. So for real-time context, we collect multiple kind of data types, data streams, as we discussed. So for example, We collect data related to weather. We have data related to visibility, the jam factor. So as you can see, this trip was taken on 14th of January. The jam factor was 1.7, which is considered to be on the higher side. The road category is 2. The traffic speed at this moment of time was 40 kilometer per hour. And the free flow speed, which basically represents the speed which is observed when there is no traffic jam. So these are the parameters, the real-time data that we collect. And now based on this real-time data, the historical data, whatever risk events that we have identified, these 3 events, we overlay all this information, the historical information, the real-time information, to assess whether, to better assess each one of these events. So if I go each intervention or risk event, you will see that this particular risk event has been highlighted because of multiple reasons. For example, this risk event happened inside an accident-prone zone. So this makes it more riskier, and the severity has been changed from medium to critical. And also the jam factor was 1.2 at this moment of time when this particular risk event happened, which is considerably on the higher side. We generally observe on the jam factor to be less than 1 when there is no traffic or very small number of vehicles driving on the road. So considering all the jam factor, considering it's a inner city road and it's happening inside an accident prone zone, we have been able to better assess it and now mark this particular intervention rather than taking it as a medium risk severity. We are now saying that it's a critical severity. So this is how each one of the events are analyzed after adding the contextual layer, and we are better able to assess the performance of the driver or better able to understand the things related to the driver safety. So this is the demo part. Now I will hand it over to Ayan, and if you have any questions, I will take it in the end. And for now, I will hand it over to Ayan and discuss further items.
Nitin, if you can stop your share, then I'll start again. Yeah, thank you. Okay, so thank you, Nitin, first of all, for deep dive into how the entire thing works. Now, I hope it is clear that, as we've discussed from the very beginning, that road safety is not simple. It is a permutation and combination of a lot of different factors. And, something that is safe for one driver can be completely unsafe for the other driver. And and that's what I would like to conclude my thoughts on. So let's say if as a company your focus is on cars, right? So, and you want to, and let's say acceleration event, so hard acceleration is of very high importance to you, depending on your business or the type of drivers that you have. Now, an acceleration event can be unsafe, can be relatively less unsafe, can be even extremely high risk, depending on, as how Nitin just showed you, depending on what the traffic is, what the traffic density is, what is what is the weather like, or what is the kind of road that somebody is driving on. Similarly, if I have to focus on something else, let's say you want to work on identifying the turning behavior for trailers, right? So on the autobahns, I want to identify that people who are renting trailers from me, what is their turning behavior, because that has a direct impact on my trailer's life or maintenance or whatever it is. So over there, it is again a function of whether they're driving on the motorway, in the city roads, what is the visibility like, and perhaps even what is the wind like, what is the traffic speed at that point in time, and so on. And finally, perhaps one of the most important and interesting discussions going on these days is distractions. Now, a distraction can both have a nominal or a very basic impact on somebody's safety, or a very high impact, and that is dependent on what is the traffic and what is the road and what is the weather like, and how much cognitive load, so how much much mental capacity does it consume as driving as an activity at that particular point in time. So those are the questions that we try to answer while being able to identify and do the same thing for a bunch of other vehicle segments. So in conclusion, what does this all mean for you and your customers? Now, at Kruzr, as I started, our goal has been to maximize the amount of value we can generate while minimizing the entry barrier. That means we utilize just my mobile phone. So as Nitin showed, it was just my mobile phone that was being used for all the risk assessment that you just saw. Now, we do that because we understand that whether you're an insurer, whether you're somebody who wants to reward or work or raise awareness about green driving, or whether you're a safety organization looking to improve road safety overall in your city, in your community, or a car rental company, or you're a young driver who's pissed as to why he or she should be paying so much premiums, or a fleet operator. Every segment within the within the mobility ecosystem is different, and the problem statements we see over there are different. And the whole approach that we at Kruzr have taken is to be able to cater to those requirements, be it for an insurer or for a young driver or for a car rental company. And the amount of contextual data and algorithms that Nitin just talked to about us helps us do that in a hardware agnostic way. So that is the thought that I would like to leave all of you with. And I give way to Ono now. So thank you again, everybody, for listening in. And if you have any questions, please do write to us, in the chat box right now, or reach out to us after this webinar. And have a good evening. So Ono, over to you.
Wow, thank you, Ayan, and thank you, Nitin. That has been quite a truckload of information that you shared. Very impressive. Now, let me ask you the following. You went at great length in explaining how you measure absolute risk and then add contextual risk. What is exactly and what can you tell us about the increase in accuracy by adding that contextual data aspect?
So, Anu, I'll try to answer that, based on my experience with mobility companies, with insurers, with actuarial teams. And the difference between having the context and not having the context is purely from a execution point of view and purely from a usability point of view is a 1 and a 0. So I'll give you one example. So as we just saw in my trip, right, where Nitin said that we've identified 3 high risk zones, but there was one high risk which was the actual accident risk when you take into account the traffic and the weather and other things. And the reason why I say that it is a difference between whether you have context or not will decide whether that data is usable for my insurance company to give me discounts, or for a road safety organization to truly understand whether I was at high risk or not, depends again on the context. If I just look at it in isolation, yes, you can have a very broad averages, but it is not really that useful when you talk about having real value in terms of driving data and using it for driving safety.
All right, excellent. Thank you. Perhaps another question relates to the wide range of mobile phones and their sensors. Maybe a question for you, Nitin. How do you take into account differences in the mobile phone sensors?
Yeah, I think this has been one of the challenging problems of using smartphones for doing any kind of telematics-based analysis, because the sensors initially were not meant to do this job. But now, as growth in the IoT domain and self-driving cars and things like that, people have figured out intelligent ways of filtering sensors or different techniques of sensor fusion to get better estimates about the sensor values. So this has been one of the helpful things. Secondly, one more thing which has been we understand in telematics that there are 3-4 major providers, the major market capturers, like Samsung, Apple, and things like that. So they capture the most market. So it is easy to standardize. If we know that for a particular device, the sensor data is not very good. So we have systems to do that also. And also our system is designed in such a way that we try to give as less false positive as possible. We know that even with best of the filters and best of the sensor fusion techniques, sometimes it's impossible to clean the sensor data. But we have, using our machine learning methods, we make sure that we don't throw false positives and give the best result only when we have the best data available, or we can do the best filtering processes. So yeah, that is about the using different types of sensors.
Okay. I have a question from the audience, and the question is, what is your take on the relationship between driving behavior contextual risk and actually being able to predict accidents?
Okay. So let me take it in a step-by-step manner, and maybe Nitin, you can jump in from a contextualization point of view. So step one of identifying any accident or predicting any accident is identifying what are the risk factors for the driver and around them. So that is as Nitin had shown, is what we start with, which is to identify in isolation whether the driver's behavior is whether the driver behavior is ideal or non-ideal. Now there are different correlations and studies about this as to what kind of behavior patterns lead to what kind of accidents and at which points in time. And that is where we further supplement it with the contextualization of whether the real-time traffic and the driver's own history, right? So, so our goal is to essentially maximize in identifying patterns which can lead to an accident, and then provide corrective actions on that. So, Nitin, anything from your side, from a pure a more quantitative approach to this?
Yeah. So if we talk about understanding the contextual risk and complementing it with the accident predictions. So, for example, a lot of countries share their accident history. So we have large amount of data available publicly, and we have analyzed and built models on the available data, which gives you that when a particular accident happened, what was the kind of traffic at that moment of time, what kind was the road category, how was the weather, and things like that. And there's a huge amount of data which is available, and we have built models and have been able to make a good understanding that what kind of things lead to accidents and how severe accidents happen in what kind of different situations which could be there with respect to the weather and traffic. And so those things have really helped us in building a very good understanding about how contextual risk is related to accidents that have been observed in different countries or in different areas.
All right, thank you. It would be really interesting to maybe in a future webinar discuss any results where a part of road accidents may be preventable and how exactly we can increase that percentage by using the contextual data. So looking at the time, I think it's a good moment to wrap up. So Ayan, Nitin, thank you. A couple of takeaways quickly. Now, traffic accidents happen because we are not aware of a risk or we choose to ignore it. There is a hazard we may not see, or we see it too late, or we let ourselves to be distracted. So in a way, when we're driving, we are, to some extent, we are blind and deaf. And on top of that, we are even sometimes stupid. So we have to respond at a later second. Even though we are aware of the severe consequences, it can happen to any of us. And I think the positive message here is that if we harness all these available data streams and are able to come up with insight and timely warnings on these hazards, on these distractions, we can jointly make a quantum leap in customer engagement, in traffic safety, or in risk-based premium settings, if that's the business you're in. So new technologies allow us to improve existing business models or even create new ones, both in insurance and mobility. Now, I believe that we share a responsibility for taking a more active role in controlling accident rates and reducing the frequency and impact of road accidents, with broad benefits to society as a whole, and at the same time improving performance in operations or portfolios. That can be done. And with today's technology, as the last hour has been demonstrated, we basically bring connected car capabilities of the future or present in a small percentage of all cars driving out there. We can bring it to all legacy cars right now. There's no excuse not to embrace it. So I want to thank you for your time and for being here very much. I hope this webinar has been useful for you to get a deeper understanding of what in fact is possible right now in telematics. A big thanks to Ayan and Nitin for sharing their expertise, and a big thank you to all participants for being here. Thank you so much. Stay safe. Bye, everybody.
Bye. Thank you. Bye-bye.
Thanks, everyone. Bye-bye.